Okay, so let's get started. Solution. The balancing in both acidic and basic medium. So let's begin with acidic medium. Now, like I said in the previous example we saw, the key elements here, we have manganese and sulfur. So we're going to solve for the oxidation state of manganese here on both sides. Notice the difference of the first question. That one was Mn2 plus. So for manganese, Mn plus oxygen is -2, and we have 4 of it, right? It will give us what? -1 because of the charge. So Mn minus 8 is equal to -1. Mn is equal to -1 plus 8, which is what? Plus 7. Plus 7 on the reactant side. Now let's do that of the products. MnO2 is sum of the oxidation states of all the elements that makes up the compound will give us what? 0. This one has no charge. So when you add all of them, it will give you 0. So Mn plus -2 times 2 is equal to 0. Okay? So Mn minus 4 is equal to 0. That makes Mn to be equal to plus 4. Minus 4 crosses over. At the end of the day, notice the change. What has happened? It reduced, right? So what comes to your mind? Reduction has taken place. Is it not? So from here, this way the process is reduction because there is a drop in the oxidation state from +7 to +4. Let's solve for on both sides. Previously we solved for this, I think. SO3 2 minus. We have oxidation state of +4. So sulfur -6 equals -2. So sulfur is -2 plus 6, which is +4 on the reactant side. While on the product side, we have sulfur to be what? This is -8 equals -2. So sulfur here is a +6, right? So there is an increase in oxidation state. So automatically it moves in this direction. This is oxidation. Oxidation. So tell me, which is my reducing agent? This one? This one? Good. So this becomes your RA, while this becomes your OA. Simple. That's how to identify it. Now, having known our oxidation and reduction, can I write this?
Yes.
Good. Remember, if you don't want to do this in your sheet, you can do it on a rough sheet. The essence of you doing this is to determine which one is oxidation and which one is reduction. Good. So now, having known our oxidation and reduction, let us write our oxidation half and reduction half equation. Oxidation half SO3 2 minus, right? Giving us what? SO4 2 minus. Is that true? Oxidation half reaction. What of reduction half? MnO4 minus giving us what? MnO2. This is our reduction half equation. Let's begin balancing. How many sulfur? Balanced. How many oxygen? How many oxygen? Where do we add water? Why this side? Is this side because we have less oxygen here. We don't have on this side because here you have more oxygen. Okay? So we are going to balance for oxygen by adding what? 1 mole of H2O. So that makes 4 oxygen, 4 oxygen, 2 hydrogen. So we add what? Proton on the right hand side. So that makes this to be 2H plus. Are we together? How many charge? Minus 2. How many charge? We have minus 2 charge here. This is minus 2. Plus 2. That makes what? 0. Is it balanced? No. Minus 2, 0 is not balanced. So what do we do? Where? To which side? This is what you should be looking at now. This is minus 2. This is here. I add here or here? I add how many electrons? Good. So if I add 2e minus on this side, it makes sense. Why? Adding minus 2 to this side balances. If I go and add minus 2 to this side, it will be minus 4 and 0. It will not balance. So that's why you add electrons on the right for oxidation. Reduction, you add electron on the left. You get it? Good. So we have balance for the first case. Let's do for the second case. Manganese is how many? How many? Oxygen? Oxygen? Now do we add water? How many? How many? 2 moles of H2O. So that we have 2 plus 2 balances 4. How many hydrogen? 4 hydrogen, right? So we add 4 hydrogen ions on this side, 4 protons. That means plus 4H plus. The balance for electron, this is 4, this is 4, this is minus 1, so 4 minus 1, 3. So we have 3H plus, 3 on this side. What on this side? No, so it means 0 on this side. Is it balanced? No. So where do we add electrons? On this side? On this side? Why this side?
Because this side has more.
It has more protons, not electrons. We add electrons on the left for reduction. So it's on this side, not on this side. You know why? If I add 3e minus on this side, it will cancel this. It's now 0, 0, so it's balanced. Not on this side, it's on this side. Can you see what I'm saying? It's on this side. Now let's check. How many charge here? How many charge here? 4, right? Minus 3. 1 minus 1. So it's balanced. So balance here, balance here. At this point, yes? Okay. This time the charge will be confusing for students. So let's do it again. Before we have 3e minus, let's balance for charge. How many charge here? 1. So it means minus 1, right? How many protons here? Plus 4, right? That gives us how many? plus 3 on the left. Now let's compare it to the right. How many do we have on the right? We have none. Plus 3 and 0, is it balanced? So where do we add electrons? Electrons are negative. So where do we add electrons? On this side. So that if you add electrons, it will now be minus 3. If you add the minus 3 here, there is problem. This will be plus 3, this will be minus 3. So, but we have to balance it. So we add electron on this side, so that it becomes what? Plus 3 minus 3, which is 0. So 0 balances with 0 on this side. Okay? So charges here is balanced with a 3 B minus. Starting. Are you catching?
Yes.
Okay. So that is what I was saying. Now, what's the next thing we do?
We balance
The electrons, right? This is 2, this is 3. So this 2 times everything here, this 3 everything here. Okay? So let's do this. 2 minus plus 3H2O giving us 3SO4 2 minus plus
6
plus
six
good. Now we use 2 on this side, we have what? There? Plus plus 6 minus giving us what? 2NNO2 plus 4H2O. What cancels? This takes this. We have 3 moles of water here and 4, so this one will go, remaining 1 here. 6 here. These those remaining how many? 2 here. So what's the reaction? Plus 2H plus. Another one is finished. On this side, which is H2. Yes. I have 3 on this side. I have 4 on this side. So I cancel this because 1 will remain. So that's why I'm getting 1. Right? So at this point, I think nothing is common again. This is what we call balancing in acidic medium. As a final check, we check our atom on both sides. How many sulfur? Sulfur, oxygen, this is 9. This is how many? The same number like this, it has to do with multiplication. 9 plus 8, that is what? 17 on the reactant side. So how many do we have here?
Yes.
Now for hydrogen. If you don't observe very well, you forget that oxygen will even be in the tree. Most of you, in fact, more than half of the class, you just go and look here to 12, and then you start saying it's not balanced, but you don't look at other places. So always look at the question. Then for hydrogen, how many? Balance, right? So acidic medium settle. Like I said before, for basic medium, what are we going to add? How many? Are we waiting down it? Okay, take it down. We shall be making use of this same equation. This is the equation for acidic medium, remember? And I said for basic medium, has OH to both sides. In fact, we are doing it like this. How many OH will you add? Because you have H, 2 moles of hydrogen ion. So what you add is 2 on both sides. So that will give us 3SO3 2 minus plus 2 NNO4 minus plus 2H plus 2OH minus. Okay? Giving us 3SO4 2 minus plus 2NNO2 plus H2O. I still have the same 2OH minus. Okay. Now the next thing we do, like I said before, these two will combine to give us water. So you're going to have 2H2O there. So it's going to be 3SO3 2 minus plus 2NNO4 minus plus 2 moles of H2O. It's giving us the whole of what we have here. This one will not change because there are no like terms. Okay? At the end of the day, what you are going to notice is you have a deficit of 1 mole of water here. See, this is 2, this is 1. So this one will cancel out. So the reaction we are going to get, our final and overall reaction will be 3SO3 2 minus plus 2NNO4 minus, what should we have? Plus H2O, giving us 3SO4 2 minus plus 2NNO2 plus 2OH minus. Stop here. Don't forget to also indicate the states of which they are. Aqueous, solid, aqueous, liquid, aqueous. So always indicate it. So with this we have solved question 2. This is for basic medium. For basic medium. While this is for acidic medium or acidic condition. Simple and straightforward. You did it correctly, right? Office. Note 6. Yeah?
Okay, as it's 2H plus 2H minus Let's say that two OH minus C should add this, make it together, maybe give it no.
You are the same. So just you are the same. It's like this neutralization reaction. Just pick one. Then combine them. That one was 6. So you just pick the 6. Because they are the same. What we combine was hydrogen ion will always react with OH minus to form water. Okay? Right?
Yes.